Hi guys, good morning. It's another lovely Wednesday, and today we're going to be discussing a new topic in further mathematics. Okay, but before that, I want us to look at a quick warm up, and our segment for warm up today would be common math errors. So we're going to be looking at some common math errors for a period of time. So let's look at what we have for today. Okay, so let's talk about squaring a negative number without a bracket. Squaring a negative number without a bracket. How do we do that? How does it work? Okay, now it's common for people to believe that when you have a minus sign in front of a number and then you square it, automatically the minus sign becomes positive, because minus times minus is plus and all that. But that's wrong, because the only time you can square the minus sign or say minus times minus is plus is if there's a bracket that covers both the number and the negative sign. For this particular expression here, what we have is the square for just the x, for just the number, not the negative sign. Okay, so take note of that. Let's look at an example. So for example, if I say minus 5 square, that's not the same as minus 5 times minus 5, and so it shouldn't be 25. It shouldn't be 25. Now, but this is what it should be. Minus 5 square means minus separated and then 5 times 5 in brackets, and then you get minus 25. Now it's a different case if we say minus 5 all squared and there's a bracket to indicate that both the minus and the 5 are squared. Then in that case you should get 25. But in this case, minus 5 square just means that the square applies only to the 5. Okay, so if you've been making this mistake in terms past, I hope that after today you won't repeat that same mistake. Okay, so that's that for our common math errors segment for today. Let's move on to our topic for today. Okay, so we're dealing with matrices. Okay, now the singular form of that is a matrix. So the plural of matrix is matrices. Let's talk about some basic concepts that are surrounding, or basic concepts that are part of matrices. Okay, now what is a matrix? A matrix is a rectangular array of numbers enclosed within brackets. A matrix is a rectangular array of numbers enclosed within brackets. Look at some examples of matrices here. Okay, so you can see minus 2, minus 2, 3, minus 5, and 1 are enclosed in a bracket. 7, 0, 9 enclosed in a bracket. 1, 3, 6, 5, 9, 4, 2, 3, 5, 4, 1, 4 are enclosed in a bracket. So those are examples of matrices. So whenever you see this kind of array, it's called a matrix. Okay, so let's move to the next thing we want to discuss. Now let's analyze this particular matrix. Now we have 2, 3, minus 5, and 1. Now we say that the numbers 2, 3, minus 5, and 1 are the elements of the matrix. They are the elements of the matrix. Okay, we call them elements. It's important that you get familiar with these terms, because as we go on, we're going to be using these terms. So it's important that you understand what we're talking about when we say elements. So now let's analyze the arrangement. Now, if we take a look at the matrix horizontally, 2 and 3 are on the same horizontal line, and minus 5 and 1 are on the same horizontal line. Okay, now this observation of horizontal lines is called the row. They are called rows. So when you look at matrices and you see 2 numbers or 3 numbers on the same horizontal line, that is referred to as a row. So 2 and 3 here make up a row, and minus 5 and 1 here make up another row. Okay, let's look at something else now. Now let's analyze it vertically now. You can see that 2 and minus 5 are on the same vertical line, and 3 and 1 are on the same vertical line. Now when we look at matrices vertically, we say each of these vertical arrangements is a column. So these are columns. Now you can see that this matrix here has 2 rows, 1, 2, and it also has 2 columns. Okay, this also has 2 columns. Now this type of matrix is called a 2 by 2 matrix because it has 2 rows and 2 columns. Okay, it's called a 2 by 2 matrix. Now in general, a matrix with m rows and n for nose, n columns is said to have an order of m times n. So when you have 3 rows, for example, and 4 columns, for example, that is a 3 by 4 matrix. When you have 4 rows and 2 columns, that is a 4 by 2 matrix. So take note of the basic notation. So when we say 3 by 3, 2 by 4, 1 by 2, you should be able to understand that the first number there represents the number of rows, which are the horizontal lines, and the second number there represents the number of columns, which are the vertical lines. Okay, so let's move on to two types of matrices that are very important to note. Okay, a matrix with just one row is called a row matrix. A matrix with just one row is called a row matrix. Now look at the example we have here. Now you can see we just have one row, one horizontal arrangement here, one row. So this is called a row matrix, and it's of the other 1 by 3. 1 by 3. Okay, that's an example of a row matrix. While a matrix with just one column is called a column matrix. So let's look at this. You can see we have one vertical arrangement here, just one column here. Okay, one column, so this is called a column matrix. Okay, and it's expressed as a 3 by 1, 3 by 1 matrix. 3 by 1 matrix. Okay, so that's that for row matrices and column matrices. It's important to take note of all these details, and internalize them so you're familiar with them. Let's talk about notation of a matrix. Now, a matrix will be denoted by a bold-faced capital letter, while the elements of the matrix are denoted by small letters with suffixes that define their position. Okay, I'm going to explain that in a jiffy. So let's look at this example. Now this is how we denote a matrix. A, the capital letter A is the what we use to denote the matrix. Then you can see A11, A12, those are the elements of the matrix. Now the numbers that you can see here help you to define the position of that matrix. So when we say A11 here, it tells us that this particular element is in row 1 and column 1, is in row 1 and column 1. When we say A12 here, it tells us that this particular element is in row 1 and column 2. It's in row 1 and column 2, and on and on and on it goes. Okay, so the element A11, like we said, is in the first row and the first column, while the element A12 is in the first row and the second column. A13 would be in the first row and the third column. A21 will be in the second row and the first column. So that's how it goes. And in general, we can say that an element Aij is in the ith row and the jth column. It's in the ith row and the jth column. Okay, it's in the ith row and the jth column. Okay, so let's move on and let's talk about how to identify these positions of elements. So find A21 in this matrix B, and you're to find A32. So A21 and A32. Now from what we've just discussed, we said A21 means the second row and the first column. The second row, this is the second row, and this is the first column. So the element in that position is 7. It's in the second row and it's in the first column. Okay, so the element here is 7. Now for A32, it's the third row and the second column. The third row and the second column. So our element here is 6. Okay, so our element there is 6. Okay, so let's move to something else. Let's talk about equality of matrices. When do we say that two matrices are equal? Now, pay attention. Two matrices that have the same order are said to be equal if all their corresponding elements are equal. If their corresponding elements are equal and they are of the same order, when we say order, 2 by 2, 2 by 2. If the first one is 3 by 2, the second one should be 3 by 2. Okay, so if they're of the same order and their elements are equal, corresponding elements are equal, then we say that they are equal matrices. Okay, so for example, we have matrix A, and then we have matrix B. Now, if we say A equals to B, if we say matrix A equals to matrix B, then A11 must be equal to B11, and A12 must be equal to B12, and A21 must be equal to B21, and A22 must be equal to B22. So that's how it goes. That's how it goes. Okay, and on it goes. So just take note of that. It's very important. Very important. Now let's take an example. For example, you're given two matrices and you're told that they are equal. You can see that on your screen. And you're asked to find, two values or thereabout, and they are unknown. So what do you do? Based on our knowledge that all the corresponding elements should be equal, we can simply say that from the comparison and by observation, x equals to 4, because x is in this position and the corresponding position here is 4. So x equals to 4 and y equals to 2. By observation, y equals to 2. So this is a simple one, right? I think it is. It's a simple one. So let's go on now to, let's talk about some calculations involving, these matrices. We've been talking about the notation, the, how it's denoted, and the basic concepts. Let's now talk about adding and subtracting of matrices. Now, I want you to understand that before you can add or subtract matrices, they have to be of the same order. They have to be of the same order. You cannot add a 2 by 3 matrix to a 1 by 4 matrix. Okay, if the first matrix is a 2 by 3 matrix, the second should be a 2 by 3 matrix for them to be successfully added or for you to subtract one from the other. So take note of that, okay? So let's just say to add or subtract matrices, what you need to do is to add or subtract the elements in the corresponding positions. I'll show you what that means in a second. Okay, so let's take a quick example on that. So we have matrix A as 2 minus 4, 7, 3, you can see the elements, and you have matrix B also. Okay, now if you're asked to find A plus B and A minus B, how do you go about it? Okay, let's start with A plus B. Now for us to add, remember that the order of the two matrices should be the same, and that is clear here. They are both 2 by 2 matrices. They are both 2 by 2 matrices, so we can go ahead and do the addition. So let's add these two together. Now what we simply do here is we take elements in the corresponding positions. 2 plus 1, minus 4 plus 6, 7 plus minus 2, and 3 plus 5. So that's what the concept is all about. You should match the elements in the corresponding positions and do the appropriate operation, either addition or subtraction. So 2 plus 1, minus 4 plus 6, 7 minus 2, and 3 plus 5. Now the only thing you need to be very careful about here is minus. When you see minus signs, especially when you move on to subtraction, you need to be very careful with minus signs. We'll talk more on that as we move on. So let's just see what the final answer should be. Of course, 2 plus 1 is 3, minus 4 plus 6 is 2, 7 minus 2 is 5, and 3 plus 5 is 8. Now let's go to A minus B. So we can put the two matrices side by side again with a minus sign in between. So as we have said already, you take corresponding elements and you subtract. So you have 2 minus 1 minus 4 minus 6, 7 minus 2. Like I said, you need to be very careful with the signs. So if I'm not careful, I could just say 7 minus 2 because I feel I'm doing minus, but there is already a minus here, so you have to be careful. So 7 minus 2 and 3 minus 5. So if we simplify that further, we should have 2 minus 1 1 minus 4 minus 6 minus 10 7. Now this becomes plus. 7 plus 2 is 9 and 3 minus 5 is minus 2. So there we have addition and subtraction. So let's move to something else quickly. Let's talk about the properties of addition of matrices. Now I'm about to give you these properties, but I don't want you to just take my word for it. I want you to try to practice and see how these properties actually applied to different matrices. So you can just come up with your own matrix and just work them out. So let's show the properties now. So let's assume you have three matrices A, B, C, for example. The first property of addition of matrices is that A plus B is equal to B plus A, meaning it does not matter the order in which you do the addition, the final answer would still remain the same. Okay, so this property is called the commutative property of addition of matrices. Now, the commutative property spreads across so many topics in mathematics, but for this is what it means. So you can test this out with two matrices of the same order and check if A plus B actually gives you B plus A. Now let's see another one. A plus B plus C is the same thing as A plus B plus C. So if you decide to add the first two matrices before adding the third, or you decide to add the last two before adding the first, you should get the same answer, and that property is called the associative property. Okay, so you can just pick three different matrices of the same order and try that property out. Okay, now, so like I said, try demonstrating these properties. If you're able to demonstrate them successfully, you can leave a comment in the comment section and let me know that you were able to get it right. Okay, let me know you were able to get it right. Let's move on now to multiplication. Multiplication. Now we're going to be looking at two different types of multiplication, the scalar multiplication and the matrix multiplication. Let's start with the easy one. The easy one, scalar multiplication. So scalar multiplication, what's it all about? Okay, what's it all about? This involves using a constant to multiply a matrix. A constant in the sense numbers like 2, 4, 5, 6, 7, 8, just numbers to multiply a matrix. Okay, so for you to successfully use a number to multiply a matrix, all you need to do is assume or regard it as if you're opening a bracket, or imagine that you're opening a bracket and use that number to multiply each and every element in that matrix. It's as easy as ABC. Okay, so what do we do here? Let's just take an example so you can get it better. So let's assume you have this matrix X given to you and you have Y given to you as this. Now I'm going to give you a mixture of scalar multiplication and subtraction. So let's assume you were asked to find the X minus 2Y. What do you do here? First of all, let's lay out our solution. So we have 3 and you can see X placed there, minus 2 and you can see Y placed there. So 3 now multiplies each and every element in this matrix now, and 2 multiplies each and every element in this matrix now. So you should have something like this. 3 times 4 gives you 12, 3 times minus 1 gives you minus 3, 3 times 3 gives you 9, 3 times 2 gives you 6. we have minus here in the middle, then 2 times minus 3 gives you minus 6, 2 times 1 gives you 2, 2 times 2 gives you 4, 2 times 5 gives you 10. That's an easy one, right? Now then we can apply our knowledge of subtraction by simply pairing the corresponding elements and subtracting them. So we should get 12 here minus 6. Like I said, be very careful with the minus signs. 12 minus 6 minus 3 minus 2, 9 minus 4, and 6 minus 10. That should give us 12 minus times minus gives us plus. 12 plus 6 is 18, minus 3 minus 2 is minus 5, 9 minus 4 is 5, 6 minus 10 is minus 4. So that's that for, scalar multiplication. It's very easy. It's very easy peasy. Okay, let's go to something a little more complicated now. Just a little more complicated. It's a bit tedious, but it's not difficult. It might be longer than scalar multiplication, but that doesn't make it difficult. Okay, so try to follow step by step and it will be okay. So for two matrices to be multiplied, first of all we need to check something. We need to check for the conformability of those two matrices. We need to check if they are conformable. If they are conformable, then we can find their product. If they are not conformable, unfortunately, we won't be able to find their product. Now, how do we know that these matrices are conformable? The number of columns in the first one should be equal to the number of rows in the second one. Okay, that's how to know if two matrices are conformable for multiplication. So the number of rows in the number of columns in the first one should be equal to the number of rows in the second one. Okay, so just take a look at this. We have a matrix A with its elements, and we have a matrix B with its elements. Now let's check how many columns do we have for A. 2 columns for A. How many rows for B? 2 rows for B. Okay, that's okay, we're good to go. So let's say the product AB is a matrix C, an arbitrary matrix C that we do not know the exact values for now, but let's see how to get each and every value inside, each and every element inside the matrix C. So let's start with C11. How do we get C11? Now C11 is easy to get. You take the first row of matrix A and multiply it by the first column of matrix B. So you have A11 times B11 plus A12 times B21. That gives you C11. So C11 is from the notation 1 the first row times the first column. Then for C22, okay, let's go to C12 rather. So C12 should be the first row times the second column, okay, of the second matrix. Okay, so we have A11. Take note of the notation, very important. A11 times B12 plus A12 times B22. Okay, now for the next element of the product, C21, how do we get C21? The notation will tell you that the second row will be multiplied by the first column. Okay, so we have A21 times B11 and A22 times B21. You add that together, you get your C21. Now for C22, from the notation C22, the second row of the first matrix times the second column. So we have A21 times B12 plus A22 times B22. So that is what we have for the matrix multiplication. Now it might look a little, if you haven't seen this before, it might look a bit confusing or a bit tedious, but it's not. Now the key to being proficient in matrix multiplication is to practice. Is to practice. Now it's important that you learn step by step for matrices, because as you go forward, you're going to have to recall what you have learned in the previous subtopic, to use that knowledge for the next one. So try to perfect your understanding of this multiplication. Let's take an example and just help ourselves to understand this better. Okay, so given that we have a matrix A there and a matrix B there, and you're asked to find AB. Okay, first of all, we need to check if this is possible, if the matrices are conformable. How many columns do we have in A? 1, 2. And how many rows do we have in B? 1, 2. Eureka! We have found it. So yeah, the two matrices are conformable, so yes, hooray, we can move on and get our AB. So let's try to begin that arrangement now. Okay, so I'll show you how all these elements in the answer were obtained. Let's start with the first one. Let's start with this. So we take the first row and multiply the first column here. So we have 3 times 4, 3 times 4 plus 2 times 5. So 3 times 4 is 12, and that gives us 12 plus 10. Then we take that same first row times the second column. That gives us 3 times 3 plus 2 times 1. So 9 plus 2 here. Then we take that same first row again and multiply by the third column. Okay, so that gives us 3 times minus 2 and 2 times 4. Okay, 3 times minus 2 and 2 times 4. Okay, so next thing is we move on to the next row, the next row here, and let's see how we got all the elements here. So we got to this next row now. So we have second row times first column. We get 4 times 4 plus 1 times 5. 4 times 4 is 16 and 1 times 5 is 5. Okay, 4 times 4 is 16 and 1 times 5 is 5. That gives us this. Then we go to the second row again and the second column. The second row again and the second column. So that gives us 4 times 3 plus 1 times 1. And that gives us 12 plus 1 over here. Then we go to the next second row again and the third column. So the third column, that gives us 4 times minus 2 and 1 times 4. Okay, 4 times minus 2 plus 1 times 4. Now we've gotten the elements in this row, so let's go to the next step. We go to the third row now, and we go to the third row times the first column. So 5 times 4 plus minus 1 times 5. Okay, 5 times 4 plus minus 1 times 5. Then we go to the third row and the second column. So we have 5 times 3 plus minus 1 times 1. Okay, then we still remain on the third row and we multiply by the third column. 5 times minus 2 plus minus 1 times 4. So this is what we have when we lay all of that out. Okay, when we lay all of that out. So that gives us if we add everything together and try to simplify, that should give us 12 plus 10 as 22, 11, 2, 21, 13, minus 4, 15, 14, and minus 14. So that's how to carry out matrix multiplication. Like I said, it's pretty important that you practice, especially the matrix multiplication. It's actually a little more complex than the addition and subtraction and scalar multiplications. Okay, so let's talk about properties of multiplication of matrices. Again, I would say please try your best to investigate these properties and get back to me if you were able to test them out. So the first one, first of all, given that you have 3 matrices A, B, and C, the first property is that AB is not equal to BA. So if we say we're going to multiply A and B, and then we do B times A, it's not going to give you the same thing. So multiplication for matrices is not commutative. Also, we have A into B plus C equals AB plus AC. So that means multiplication distributes over addition, so it is distributive. It is distributive. Now AB times C equals to A times BC, so it's associative. It's also associative. So like I said, try to determine this properties. Just pick 3 abstract matrices of your choice as A, B, C. Remember to make sure that they are conformable for multiplication when you're dealing with multiplication, of course. Remember to check for that. Now, if you try them out and you're able to get the confirmation of each of these properties, leave me a comment in the comment section. Okay, all right. Now, in the light of everything we've discussed, I'll be giving you some practice questions to just try out on your own after watching the class. But let's quickly take a summary. What have we talked about today? We've talked about all the basic concepts of matrices and the notation, how they are denoted. We moved on to talk about addition and subtraction, and we just said you would add corresponding elements or subtract corresponding elements of these matrices. Then we talked about scalar multiplication, which involves using that number to multiply each element in the matrix. And then we moved on to the matrix multiplication, which involves using the rows of the first matrix to multiply the columns of the second one. And you remember that they need to be conformable. The number of columns in the first must be equal to the number of rows in the second. So that's a quick recap or quick summary of everything that we have said today. Of course, there's a lot more on matrices in general, so we're going to continue from here in our next class, and I'll be giving you some special matrices, telling you about some special matrices, and we'll do a touch of determinants. So I would now show you the questions I want you to try out. So you can just pause the video and try to solve these questions that you can see on your screen, okay? Or you can come back and do the solution, but nevertheless, whichever way you decide to go, if you're able to get the answers, you could try to leave me the answers in the comment section and let me know if you got it right. Okay, you could also visit quizzes.com and try to find some practice games on matrices, okay, if you can. Now, we're going to end the class here for today. It has been lovely teaching you guys today. I hope you continue to have a great day. Remember to leave your comments, like the video, and share to your friends. If you've had a nice time today, I'll see you guys again, same time, same day next week. Have a wonderful day. Bye bye.